Hello, Algebra 2, and welcome to the 6th section of this chapter. This is actually the last section that we're going to cover in this chapter. There's one more, but you'll see that next year in pre-calc. This section is about identifying conic sections. So we're going to continue to practice this objective of writing equations of conic sections in standard form, just that in this section they're all mixed together. And we're going to practice looking at their equations and identifying which kind of conic section it is. So this is actually a really good review of all of the different kinds of conic sections that we've talked about. So the first part of this section is about conics that are written in standard form. So the equation for any conic, I can always write it out: ax squared plus bx plus cy squared plus dx plus ey plus f equals 0. I can write it out that long way, as long as a, b, and c are not all 0. That's kind of a general form, and we can change it into the standard forms that we've been working on for this whole chapter by completing the square. Right? So when I complete the square, I get circles, parabolas, ellipses, or hyperbolas. A circle can only look one way, because a circle can't be horizontal or vertical. And then I have parabolas. If my parabolas are horizontally, sorry, I think I have my parabolas, backwards here. So parabolas, if I have y equals something with x squared, we know it opens vertically. And if it's x equals something with y squared, we know it opens horizontally. Sorry, I got those switched. And then ellipses, remember ellipses are added together equal to 1. So this is what it looks like if it opens horizontally versus vertically. Remember, it depends on where that main axis is. And then hyperbolas are subtracted and equal to 1. And again, whatever is under the positive term gives me the axis that goes between my vertices. So let's just review of what the equations look like from what we've looked at before. So this is great practice for rewriting using completing the square and then identifying what kind of conic section it is. So in this first one, we're going to rewrite this equation. We have 16x squared minus 25y squared minus 128x minus 144. And we need to rewrite that in standard form, decide what kind of conic section it is, and then graph. So what I like to do first is to rewrite this just with my x terms together, my y terms together, and then I move the constant to the right-hand side. So that just sets me up for completing the square. I'm going to factor the 16 out of my x squared, and then I know I'm going to have to add something in there. My y term, since there's only a y squared and not like another y term, I don't have to complete the square on this. This is like y minus 0 quantity squared, and then that's just equal to 144. So now the question is, what do I need to add to complete the square here? Well, half of negative 8 is negative 4, squared is positive 16. So I'm adding a 16 here, but remember this is really 16 times 16. So on this right-hand side, I need to add, not multiply. I need to add 16 times 16. Let me get rid of this line so it doesn't confuse us later. And so this is 16 times x minus 4 quantity squared. Then I just have minus 25y squared equals 400 when I do 144 plus 16 squared. Sorry, that's a 400, not 460. And now I'm going to divide everything by 400 to make this equal to 1. And so my final equation looks like x minus 4 quantity squared over 25 minus y squared over 16 equals 1. So what is this conic section? Well, it's equal to 1, and these two terms are subtracted. This is a hyperbola. So in order to graph it, we know that our center here is going to be at positive 4, 0. So you'll have to draw in some axes on your graph, and then here is my center. Oops, it'll let me draw at 4, 0. And then from that center, I'm going to go 5 units to the right and 5 units to the left. This is going to be a horizontal hyperbola because my x term is positive. So 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the left. Or no, I should be going 5, right? 1, 2, 3, 4, 5. There, I think I fixed that. And then this gives me my other axis, like conjugate axis. So I go 4 units up, 1, 2, 3, 4. So remember the square root of 16 is b, and then down 4. And that makes my rectangle. It looks like I should have drawn my axes a little bit differently to give myself more room to graph, but remember that my asymptotes go through the diagonal, and hopefully you'll use a ruler and do a more beautiful job than I am doing here on my little board. But I draw my asymptotes through the diagonals of my rectangle, and then I can draw in my hyperbola. This will be the vertex of my hyperbola, so it's going to come infinitely close over here, come and touch that point. Again, hopefully you'll be able to draw smoother than I can, and come down here. And then I have the same thing over on this side. This is my other vertex, so we're going to have to draw it a little off the graph, but hopefully you get the idea, and that is what my hyperbola would look like. All right, you guys try this one. All right, your answer here should be an ellipse, and the answer that you should have chosen is B. X minus 2 quantity squared over 9 plus y plus 4 quantity squared over 36 equals 1. And then your graph should look like this. Notice that the center is at 2, negative 4 right here. And then I go 3 units to the right, 3 units to the left to get my co-vertices, 6 units up and 6 units down to get my vertices, and then I can draw my ellipse. All right, what if we don't write our equation in standard form? If we don't write our equation in standard form, there are still ways to figure out or to determine what kind of conic section it is without having to rewrite it. When there's an xy term, which means b is not equal to 0, we can use the discriminant, which is interesting. They do the same kind of discriminant that we did back with quadratic functions. That's the discriminant of this general form. So notice a is the coefficient of x squared, b is the coefficient of xy, c is the coefficient of y squared. This table kind of summarizes for you what you need to know. If my discriminant is negative and b is 0 and a is equal to c, then I have a circle. If my discriminant is negative and either b is not 0 or a is not equal to c, then I have an ellipse, which makes sense because it's like a circle, but it's stretched out. So the difference is here in the b's and the a's and the c's, but the discriminant is still negative. If my discriminant is equal to 0, I have a parabola. And if this discriminant is positive, I have a hyperbola. So you'll need to know how to do that. When b is equal to 0, my conic is either going to be perfectly vertical or perfectly horizontal. When b is not 0, and remember, just from looking back here, b is the coefficient of xy. When b is not 0, my conic will be slanted. We haven't practiced graphing those kind of conics. It's just like a piece of information for you to know. So here I have an ellipse where b equals 0, so it's horizontal. Here I have an ellipse where b is not equal to 0 and it's rotated. So not everything has to be perfectly horizontal or vertical, although that's what we are practicing in this chapter. This is just to let you know that's not always the case. So again, identifying conics, this is another way to figure it out. If b equals 0, this is another way to decide what kind of conic it is. If a or c are equal to 0 but not both, I have a parabola. If a is equal to c, I have a circle. If a and c have the same sign, so they're both positive or both negative, but they're not the same numbers, they're not equal, then it's an ellipse. And if a and c have opposite signs, so a is positive and c is negative or vice versa, then I have a hyperbola. So let's take a look at this example. We're going to analyze an equation without, notice it says without writing it in standard form. So without writing it in standard form, we're going to figure out, is it a parabola, circle, ellipse, or hyperbola? So let's look at part A. In part A, we have an ellipse. Why? Well, we know that if I identify my A, B, and C here, A is 4, B is negative 3, and C is 1. So my discriminant is negative 3 quantity squared minus 4 times 4 times 1, which is negative 7. So I have a negative discriminant, so that's going to make it a circle or an ellipse, and b is not equal to 0, so this is going to be an ellipse instead of a circle. If I look at part b, again I'm going to say, okay, what are my a, b, and c in this case? A is 3, b is 2, right, coefficient of the xy term, and c is negative 5, the coefficient of y squared. So my discriminant is 2 squared minus 4 times 3 times negative 5, which gives me positive 64. Since my discriminant is positive, if you look back at your chart, that means that this has to be a hyperbola. And last but not least, again, identify a, b, and c. So in this case, a is 0 because there's no x squared term. B is 0. There's no xy term. And c, the coefficient of y squared, is 4. My discriminant is 0 squared minus 4 times 0 times 4. Just gives me 0. So this has to be a parabola because my discriminant is equal to 0. All right, try part A on this one. All right, hopefully you said that this one was a hyperbola. You should have gotten a discriminant that is positive. Your discriminant here should have been 4 squared minus 4 times negative 6 times 8, which gives me 208, so a positive discriminant. All right, try part B. Okay, part B, you should have also gotten a hyperbola. When you do your discriminant for this one, you get 3 squared minus 4 times 4 times 0, so we just get a discriminant of 9. Positive discriminant means I have a hyperbola. And now do part C. All right, for part C, you should have an ellipse. A is 3, B is 0, and C is 2, so my discriminant is 0 squared minus 4 times 3 times 2, so I get a negative discriminant here of negative 24. So my discriminant is negative, that means it's ellipse or a circle, but A is not equal to C, so that means that it is an ellipse. All right, that's the end of this section. I will see you in class to do some more practice. Make sure you wrote down any questions you have.